Morning, dear students. Welcome to this session on prestressed concrete. We are talking about Unit 4, how to find the moment of resistance. So, last session we have talked about finding moment of resistance using the Codal formulas. So, just going through again those formula. So, this is one such formula we talked about in the last session. So, moment of resistance is equal to FPB, which is to be found from table 11, area of pre-stressing steel, okay, effective depth of the section, and XU again to read from the table 11, depending on the value of APS FPU divided by BD FCK. For a particular value of this, you have to read these values from the table and find FPB and XU to substitute into this equation to get moment of resistance of rectangular sections or the flanged sections where neutral axis lies in the flange. Okay, and we have seen another formula for a case of flange sections with neutral axis falling outside the flange. Okay, for that the formula from textbook I read. So little change in the notations. So to match with the code notation, it is to be understood that FPU is nothing but FPB and remaining all same. APW D minus 0.42 XU 0.45 FCK BW width of the flange, width of the web, depth of the flange, width of the section, overall width of the section. Okay, all that. So FPB into APW, area of pre-stressing steel for web, okay, D minus 0.42 XU plus 0.45 FCK. B minus BW into DF is the compressive force multiplied by the lever arm D minus 0.5 DF. Okay, so to find APW, which is required for reading the values of FPB and XU from table 11, you need APW value. So that is found from total area of steel minus area of steel for flange. Area of steel for flange is calculated by equating tensile force is equal to compressive force pertaining to flange. Okay, so that is this one. Once you get APW, the formula that is available in IS code will change, a little change. Instead of total area of steel, you have to substitute only APW and FPU is as usual. And instead of B, you have to use web width. Okay, width of web. D is as usual and FCK. So in the formula, a little change. Instead of APS, APW we will use. For this is only for a case of flange sections with the neutral axis falling outside the flange. Okay, so that is how we use these formulas and we get FPB value, XU value to read from the table 11. Okay, now let us see an example. Okay, a pre-tensioned pre-stressed concrete beam having rectangular section 150 wide, 350 deep, has effective cover 50 mm, and if FCK 40 megapascal, FP, I mean textbook notation is FP and code notation is FPU. Okay, right? FP is equal to FP is equal to, code says it is FPU, characteristic compressive strength 1600 megapascal. Right, area of pre-stressing steel is given 461 mm square AP or APS, both are same. Calculate the ultimate flexural strength of the section using, it's not 18, it is IS. Some typographical errors are there in the textbook. Just be careful when you are reading it. Okay, so make necessary corrections wherever you find a mistake. IS 1343 2012 latest code. Okay, right. So FCK is 40, FP is 1600, AP is 461, B is 150, D, capital D is 350. 50 effective cover is given. I mean, from center of steel to the bottommost fiber 50 mm. So effective depth becomes 350 minus 50, 300. Okay. Now the effective reinforcement ratio. I mean, to read from the table 11, you need to calculate APS, the formula that is available there. APS FPU divided by BDFCK. Okay, so what is FP 1600? What is AP 461? FCK BD. Okay, so that is coming to 0.4. So from table 11, go to table 11. So this value is 0.4, I mean the last value. So for a pre-tension member, it is given in the question, pre-tension member, FPB divided by 0.87, FPU is equal to 0.9 and XU by D is 0.783. So take those two values. Right, so you see that FPB divided by 0.87 FP is zero point 0.9, XU by D is 0.783. Okay, so now FPB value or FPU both are same, 0.87 into 0.9, 1600, nothing but 1253 Newton per mm square. And XU by D is 0.783 into D is 300. So 234.9 is the depth of the neutral axis. Okay, and now substitute those values into MU, where FPU 1253, area of pre-stressing steel 461, D minus 0.42 XU. So that is 116 into 10 power 6 Newton mm, nothing but 116 kilonewton meter, the moment that it can resist. Okay, so this is how simple you can solve. It's only to calculate whatever is required, the effective reinforcement ratio to be calculated from the IS code. Table 11 shall be read accordingly. Okay, so always use page number 51 no, to read these values of FPB divided by 0.7, 0.87 FPU. Okay, so there is a little no difference in the codal notations. So what you are reading is FPB divided by 0.87 FPU. Okay, so this is you are reading. So see that textbook says FPU, code says FPB. Textbook says FP and code says FPU. Okay, so be careful with this notation changes. XU by D no change, same. Okay, so that is how you have to calculate this value. Right, going to the next example. A pre-tensioned T section has a flange 300 wide, 200 thick. The rib or web 150 wide, 350 deep. The effective depth of cross section is 500. And AP is 200 square, area of pre-stressing steel. And it is used 50 grade of concrete, M50 grade of concrete. And again, FP is 1600 Newton per square, which is characteristic strength of steel. Estimate ultimate moment capacity of T section using Indian Standard Code regulations. So all the given data is presented here. FCK 50, FP or the code notation is FPU, both are same. B is 300, D is 500. It is given in the problem itself. Width of the flange 300, 200 thick, 300, 200 thick, and web is 150 wide, 350 deep. So this is 300, this is 200, and this 150. 350. So this is 150, this is 350. So effective depth of the cross section 500 mm. I mean from here, this is 350 plus 200, 550. So steel is at 50 mm from bottom. Effective cover again is 50 mm. This is 500. This is 500. Okay, effective depth. Right now, to get first, we don't know whether neutral axis falls in flange or web. Okay, so what we do, we assume that to use that codal formula, we assume that neutral axis falls in the flange itself within this flange. Okay, so that is why B will be 300 for all these computations. So use the formula again, FPU APS table 11 again, BDFCK. Okay, so what is FPU? 1600. AP, I mean APS, both are same, 200 divided by FCK 50, B 300, D 500. It is 0.04. So go to table 11, 0.04. It is almost 0.05. Okay, right? So it is 1 pretension and 0.109. If you want exact value for 0.04, you have to interpolate between these two values, 0.025 and 0.05. So if you don't, if you not to go to too much of calculations, just pick up the near value. Okay, so 0.04 1 is FPB by 0.87, FPU value is 1, XU by D is 0.109. Let us see what textbook has taken the values. Right, so 1 0.09. Okay, so these two are the values that are being read from the table 11. Okay, right, so there is a mistake in the textbook reading. It is 1.09, I think, table 11, 0.109. Okay, 0.109. Right, so accordingly change that value, 0.109. That is the mistake here. Right, FPU is okay, 0.87 FP, right, 0.87 FP into 1, so no change, 1392. And XU is 0.109 into 500. Okay, so somewhere around the value, or else point 1. Okay, so if you just round it off to 0.11 into 500, it is roughly no, it will be like 50 mm or 55 mm, roughly around 55 mm. Okay, so 55 mm from top is XU, so it is depth is 250, I mean 300 wide, 200 thick, this is 200. Okay, so only 50 mm, this is the neutral axis position, around 55 mm from top. So only if it is more than 200, then it is going to fall in the web. Okay, so that's why for the case that is being taken, the assumption that we have made is correct. Hence, you can use the formula mu is equal to FPU AP D minus 0.42 XU. So substitute all those values that you read from the table and also the given data. D value 0.42 XU, you have to change it. It's not a correct value. Just calculate for 0.109 into 500, then use that value. Okay, so you will get around 135 roughly kilonewton meter is the moment of resistance value. Okay, so this is how you are able to calculate for a case of rectangular section. And for a case of flange section, we start with the assumption by assuming, because we don't know whether neutral axis falls in the web or flange. So accordingly, we change the formula once we know whether it is falling in the flange or web. So first you have to assume to fall neutral axis to fall in the flange itself, so that you can use this formula. Okay, if you find that it is not falling in the flange, then you can change the formula for the third case, neutral axis falling in the web. Accordingly, you can calculate the moment of resistance value. Okay, right, okay, we'll see some more problems in the next session.